Hello everyone, welcome to CodersArts. This is the 7th video of the Streamlit tutorial series. In our previous video, we covered the basic of Streamlit, setup environment, creating simple applications, interactive widgets, and data visualizations. And in our last video was all about creating interactive dashboards. If you have been following along, you have got a solid foundation for what we are going to do today. Now in this video, we will see how to create predictive application with Streamlit and machine learning. Here, I will explain two created predictive application. The first model uses the famous iris dataset to predict flower species, and the second model tackles the exciting task of predictive house prices. So let's start with the iris dataset to predict flower species. Before moving ahead, I want to clarify that we will not be discussing model accuracy. My aim is to provide you with a clear demonstration of how Streamlit can be utilized to generate predictive output, emphasizing the applications and utilizing of these powerful tools. So let's begin. Here, I have already written the code and I will explain it step by step. So let's start. So let's see the first flower species prediction. Here you can see I start by importing the necessary libraries. Streamlit is of course for creating our web application, pandas for data manipulation, load iris for the iris dataset, random forest classifier for the machine learning model, and joblib for saving and loading our data model. Next here I import the data and store it in a iris variable. Now this code effectively separate the dataset into two parts, X containing the features and Y containing the corresponding target values. I create an instance of the random forest classifier model, train it on the dataset. Think of this as teaching the computer to recognize different iris flower species based on their characteristics. Here I saved the trained model to a file named model.pkl. This allows us to use the trained model in our Streamlit applications. Now I create our Streamlit interface. Here I set the title Iris Flower Species Prediction for our application. Here I create a text input field in a Streamlit for user to enter measurement of sepal and petal dimension in centimeters. Then here I use joblib.load function to load the model we saved earlier. It's like having our trained model ready to make prediction. Now we will check if the input fields are filled and make prediction. Now this line check if all input fields have entered. If yes, it create a list of user input and make prediction using the loaded model and display the predicted species. If not all fields are filled, then this message will display on the screen. Please enter value in all input fields to make a prediction. Now let me run this code. After running this code, your browser will automatically open. It will take some time to load. Now here you have to add some input values. I enter here random values. After entering all the values, you can see the output predicted species Virginica. And if I leave any field blank, then this message will show. Please enter values in all input fields to make a prediction. Now let's see another example. This is the house price prediction model. Here I also import the libraries like Streamlit Pandas, Random Forest Regressor, Standard Scalar, and joblib. Then I load the dataset here using a pandas data frame. In the dataset, there are many columns that are not important for building the model. So that's why I select the important columns for modeling. Here I create a new data frame by selecting only the columns specified in the important column list. from the original data frame. Now here, I separate the features from the target variable by creating a data frame, X containing all the column except price column. So X contain the input features and Y contain the output to be predicted. Here I retrieve the names of the features column, and these names are stored in the feature names variable for reference in the machine learning model. Here I create a scalar object for feature scaling and apply it to features column to ensure all the features have a mean of 0 and standard deviation of 1. This is a common pre-processing step in machine learning. Now here I create an instance of the random forest regressor model and fit the model on the dataset. Here I save the trained model to a file named model.pkl. Here I set the title for this house price prediction. For each feature in feature names, I create a text input field using Streamlit st.textInput for users to enter values for each features, and I store those values in the input values dictionary. Here I use joblib.load function to load the model we saved earlier, as we did in the previous model. Now here I set the condition if all the input fields are filled with values. If yes, it collects those values from the input value dictionary, convert them to a floats and store them in the user input list. Then the scalar.transform function transforms the user input data into a scaled format, preparing it for use with the machine learning model. Then here I use the trained machine learning model to make prediction on the scaled input data. And if the above conditions are true, it displays the predicted house price with 2 decimal places. And if not, then this message will display on the screen. Please enter values in all input fields to make a prediction. Now let's run this code. Here you can see the title of the top of the page, house price prediction, indicating the purpose of the application. Below the title, you will find input fields for various house features such as bedroom, bathrooms, square foot living, and others. These input fields allow you to enter the values of these features. Now I entered the random details. Now I entered all the details and you can see the model predicted the price successfully. So that's it for today. In this video, I provided a practical demonstration of how to create a predictive application using Streamlit and machine learning. We focused on the application and utilizing of Streamlit as a powerful tool for building data-driven interactive application. I hope you found this information valuable and enjoyed the tutorial. In the next video, we will explore an exciting new topics. Thank you for watching and stay tuned. See you in the next video.
If you want this kind of implementation or have any other project in mind, contact us today. You can find our contact information in the video description below.